Good day, everyone. This is Cristine Joyce, and together with my partner Clariss Ann Ladica, we'll discuss to you all the certainty factors. First, let us define what is the meaning of certainty and factors. Certainty is a fact that is undeniably true or an event that will undoubtedly occur, or in Tagalog, katiyakan. Factors, a number or quantity that produces a given number or expression when multiplied by another. In Tagalog, mga kadahilanan. The meaning of certainty factors is a number to measure the expert's belief, or it requires the experts generate minimal number of numbers and allows for quick computation of solutions. And the maximum value of the certainty factor is positive 1.0, and the term used is definitely true. And the minimum is negative 1.0. Term used is definitely false. So here is the table for uncertain terms, the term and the equivalent certainty factor. Definitely not is negative 1.0. Almost certainly not is negative 0.8. Probably not is negative 0.6. Maybe not is negative 0.4. Unknown is negative 0.22. Positive 0.2. Maybe is 0.4. Probably is 0.6. Almost certainly is 0.8, and definitely is 1.0. These uncertain terms are used frequently in research, questionnaire, and other surveys, as far as I know. And for example, if the expert states that some evidence is almost certainly true, ACF value of it is 0.8 would be assigned to this evidence. So the certainty factors and evidential reasoning. In expert systems with certainty factors, the knowledge base consists of set of rules that have the following syntax. If evidence, then hypothesis with certainty factors, where certainty factors represents belief in hypothesis given that evidence has occurred. So if evidence has occurred, then certainty factor represents belief in hypothesis. The certainty factors theory is based on two measures. The measure of belief, two functions the measures of belief and measures of disbelief. And this formula is for measure of belief and measure of disbelief. Prior probability of hypothesis is being true, and the probability that hypothesis is true given evidence. The values of measures of belief and measures of disbelief range between 0 and 1. The strength of belief or disbelief in hypothesis depends on the kind of evidence observed. Some facts may increase the strength of belief, but some increase the strength of disbelief. So here, the total strength of belief or disbelief in hypothesis. An example, if A is X, then B is Y. An expert may not be absolutely certainly that this rule holds. Also suppose it has been observed that in some cases, even when the if part of the rule is satisfied and object A takes on value X, object B can acquire some different value. For example, is if A is X, then B is Y. And the equivalent of this B is Y is 0.7, which the term used is probably. And the B is Z, then B is Z is the term used is 0.2, maybe unknown 0.2. The certainty factor assigned by a rule is propagated through reasoning chain. This involves establishing the net certainty of the rule consequent when the evidence in the rule antecedent is uncertain. Certainty factor, hypothesis, and evidence equals to certainty factor evidence times certainty factors. For example, if sky is clear, then the forecast is sunny. And the equivalent of this forecast is sunny is 0.8, which almost certainly. And the current certainty factor of the sky is clear is 0.5. Then the certainty factors is 0.4, because 0.5 times 0.8 is equal to 0.4, and the result can be interpreted as it may be sunny, because the term used for 0.4 is maybe, and it may be sunny. So that ends for my discussion, and the next slide will be tackled by Clariss Ann Ladica. Thank you.
Good day. I am Clariss Ann Ladica, and I'm going to continue discuss about our topic, certainty factor. For conjunctive rules, such as if evidence 1 and evidence n, then hypothesis and the CF value. Here we have given the formula. In this formula, we are using the minimum value of our evidence. So for example, if sky is clear and the forecast is sunny, then the action is wear sunglasses and the CF is 0.8. The certainty of sky is clear, our evidence 1, and the certainty of the forecast of sunny is 0.7, our evidence 2. Then the certainty factor of hypothesis and a certainty factor of hypothesis, evidence 1 and evidence 2 equals minimum. So, as the formula, we are using the minimum value of our evidence. As you can see, the minimum value of our evidence is 0.7. So, 0.7 is used here times the certainty factor, which is 0.8. Then, the answer is 0.56. Next is disjunctive rules. For disjunctive rules such as if evidence 1 or we are using or logic here, evidence of n then hypothesis and CF value here. In the conjunctive rules, then the conjunctive rules uh, we are using the minimum value of the evidence, where in the disjunctive rules we are using the value of maximum value of the evidence. For example, if sky is overcast or the forecast is rain, then the action is take an umbrella. The CF is 0.9. The certainty of sky is overcast is 0.6, the evidence 1, and the certainty of the forecast of rain is 0.8, our evidence 2. Then our CF, H, evidence 1 and or evidence 2 equals maximum. We are using the maximum value of our evidence, which is the 0.8. So here, 0 is being used times the 0.9, our certainty factor, equals the 0.72. Next is when the same consequent is obtained as a result of the execution of two or more rules, the individual certainty factor of these rules must be merged to give a combined certainty factor for a hypothesis. Suppose the knowledge base consists of the following rules. This is an example um, on merging. This is an example for merge. Suppose rule 1, if A is X, then C is Z. And rule 2, if B is Y, then C is Z. C and the CF is 0.6 and there in rule 1, the CF is 0.8. Take note that our hypothesis here is the same. So we will going to merge. And also take note that our certainty factor value here is different. So the question here is, what certainty should be assigned to object C having value Z is both rule 1 and rule 2 are fired? So, common sense suggests that if you have two pieces of evidence, A is X and B is Y, from different sources, rule 1 and rule 2 supporting the same hypothesis, which is CSZ, then the confidence in this hypothesis should increase or positive and become stronger than if only one piece of evidence had been obtained. So here, the formula on how to merge or combine certainty factor. This is the equation. If CF1 is greater than 0 and CF2 is greater than 0, then we are going to use this formula. Take note that this is both positive since this is both greater than. And if CF1 is less than 0, which is negative, or CF2 greater than 0, positive, then we're going to use this formula. If CF1 is less than 0 and CF2 is less than 0, which is both negative, so we're going to use this formula. Excuse me. Take note that our formula is different. If both positive, then you are using minus. And if negative and or positive, then we are using this formula. 1 minus the minimum which is the evidence. Then if both negative, so we are using the 1 plus CF1. So okay, here is the example on how to merge or combine the certainty factor. This rule is from the previous slide. So we're going to solve this. Rule 1, if A is X, then C is Z, CF is 0.8. Rule 2, if B is Y, then C is Z, CF is 0.6. Uh, Here we assume that the value of our certainty factor and of evidence 1 and evidence 2 is 1.0. CF1 H and evidence equals CF evidence 1 times the CF1. This is the formula and we're going to substitute it. The CF here of our evidence 1 is 1.0 and times the 0.8, the certainty factor of rule number 1. Certainty factor of our rule number 1. So equals 0.8. Then in the certainty factor 2, well, also 1.0, the CF of evidence 2 times the certainty factor of rule number 2. And the result is 0.8. So here we're going to merge. In this formula, we're going to merge. CF1 hypothesis evidence 1 plus CF2 hypothesis evidence 2 times 1 minus CF1 hypothesis evidence 1. Take note that since our certainty factor here is both positive, then we are using the formula, then we are using this formula. Uh, and here we're going to substitute. The value of CF1 is 0.8 and the value of CF2 is 0.6 times 1 from our formula. This is constant from our formula, minus 0.8 the CF1 is equals to 0.92. So here is the answer. Next is the certainty factors theory provides a practical alternative to Bayesian reasoning. The heuristic manner of combining certainty factors is different from the manner in which they would be combined if they were probabilities. Then, the certainty theory is not mathematically pure but does mimic the thinking process of a human expert. And here we have Bayesian reasoning versus, this is versus certainty factor. In Bayesian reasoning, probability theory is the oldest and best established technique to deal with inexact knowledge and random data. It works well in such areas as forecasting and planning where statistical data is usually available and accurate probability statements can be made. So this two is not used, if this two is not used, then we are using the certainty factor. However, in many areas of possible applications of expert systems, reliable statistical information is not available or we cannot assume the conditional independence of evidence. So as a result, many researchers have found the Bayesian method is unsuitable for their work. The dissatisfaction motivated the development of certainty factors theory. So in certainty factor, although the certainty factors approach lacks the mathematical correctness of the probability theory, it outperforms subjective Bayesian reasoning in such areas as diagnostics. And certainty factors are used in cases where the probabilities are not known, take note, are not known, or too difficult or to obtain. The evidential reasoning mechanism can manage incrementally acquired evidence, the conjunction and disjunction of hypotheses, as well as evidences with different degrees of belief. So this two is for getting the hypothesis. And next is the certainty factors approach also provides better explanations of the control flow through a rule-based expert system. And that's all. Thank you for listening.